All right, welcome back. So last time we talked about the four classes of atomic vectors that we're going to be going over in detail in this class. And those were the logical, integer, numeric, and character vectors. And we said that there are two others. There's raw and also complex, but we're not going to be really interacting with those in the health science context, especially not in this class. All right, so some examples. I can build a vector of me, the ages for me and my siblings, and also another vector of our names. So we've got a vector of ages, 31 to 21. We're all about 2 years apart, and then a vector of names. This is a few years ago. I am no longer 31 years old. Sorry. Um, anyway, so we've got ages in one atomic vector and names in another atomic vector. And this is something that I talked about last time, or maybe last lesson, when I talked about projects, and that was naming things. Because this is a vector of what I am intending to be integers, I'm going to put underscore int to say that this should be integers. Now, I didn't actually make it integers, and we'll talk about that in a little while, but I intended for it to be integers, and you can see that from the naming here. And then this is supposed to be a character vector, so I used underscore char. Now, let's create a vector like a user ID or a user profile or something. So I'm logging into a system, and that system may need some information about me. Like, for instance, it may need my last name, my first name. If it's in the hospital system, it needs my terminal degrees, may need how old I am. It may need the city that I live in. It may need the state that I'm living in. It may need my state or country of origin, and then how long was I employed. So I built this vector. I think I was working at the university. I was working at the university hospital at the time, and I had been working there for about 2 years. So this vector, I could have all of this information in this vector. Now, this is where I'm going to leave you with an exercise. I want you to think about why 31 and 2.1 are in quotes, and go back to the idea of what it means for a vector to be atomic. So again, a vector in R is a set of a collection of elements that has an ordered collection of elements. An atomic vector is an ordered collection of elements that all share the same type of information or the same class of information. So take a second. I'm going to pause the video here. Okay, so you've had a second or two or a minute or two. You can discuss this over with your neighbors, and then tell each other, talk to each other about why you think the 31 and the 2.1 are in quotes. Okay, so now let's talk about getting information out of an atomic vector like this. So if I wanted to find out, well, who is the third sibling in the ordered set of siblings, then I would say, all right, I want to use the single square bracket. So I'm going to type the object, use the single square bracket to say, okay, I would like to go into this object and extract some information out of it. Well, which piece of information do I want? I want the third piece of information. So I've got single square bracket 3. So single square bracket tells R that we're going to go inside the object and we want to pull some information out of it. Then R is going to ask the question, well, which information do we want to pull out of it? And that's where I type the number 3, and that says, give me the third piece of information. So you can think about like walking up to the case of pastelitos at Vicky Bakery or something, and you say, okay, I am standing in front of this case, and I would like something out of this case. So the action of walking up, so the case is there, right? So this names object is there, but nobody's bothered with it, nobody's messing with it. But it's your turn. You're going to walk up to the counter and you're going to say, I want, yo quiero, or you would like to order, and then you have to tell, and then the person's going to say, well, what do you want? Okay. So this is the I would like command. Like, I would like something in that case. I want you to get me something out of that case. And the person behind the counter says, well, I don't know what you want. I can't read your mind. You have to tell me what you want. And then you say, I want the third thing. I want the croqueta. I want the pastelito de coco. I want the tequeño or something like that. And so you're going to say, give me the thing in that third position, whatever that third position is. This is the chicken empanada. Give me that thing. So I've got an object here. It's an ordered set of objects, and you're telling R with the single square bracket, I want something out of it. And then you have to tell R, well, what do you want out of it? All right. So this square bracket, again, and because everything in R is an object, this square bracket is also an object, and it's technically a function because functions do things. You are requesting for the third item, or the third item of this vector, and so this single square bracket is a function that's going to be doing some work for you. Now, if I wanted two names, so these are the two boys in the family. I can create another atomic vector right here that contain 1 and 3. And then you would say, okay, I want to take the names vector and I would like something out of it. So that's what this single square bracket is saying. The single square bracket is saying, I want something out of this vector. And then R is going to ask us, well, which things do you want out of this vector? And you say, I want the first and third thing. Okay. And in order for R to understand, you can't just type 1 comma 3, but you have to make it its own vector right here. So that's why we're using the C function. Okay. Here's an exercise for you. I'll let you work on it on your own time. Now, you could walk up to the counter and say, okay, well, I am really hungry. I want one of everything in this case because my friends and I are hungry, except I really don't like the, what is it? There's there's like one of those ham sandwiches that had the olives in it, and the green olives. I don't really particularly care for that. I don't remember what it's called. But anyway, so you go up to the bakery counter and you say, I want one of everything except that one. I don't want that one. Well, this is called negative position subsetting. So this says, okay, give me the names vector. Give me this. You've got this case of all of these objects to choose from, an ordered set of elements, and I want something out of it. So that's this square bracket right here says I want something out of this vector. If I say I want -2 out of that, that is telling R I want everything except for the second thing in this object. Okay. So we don't want Brittany. She was adopted anyway, so nobody cares. Nobody loves her. I'm kidding, Brittany. Anyway, so we've got this names object, and we say I want everything except for the second object. So that's this idea of negative position subsetting. You say I want everything in the case except for that empanada. I don't like that empanada, or I don't like the ham croquetas. Okay, so I want everything else except for that thing right there. So that's the negative position subsetting. Okay, and then here's another exercise for you. Now this is where we get into, we have to do a little bit of thinking, and there's a little bit of math/logic that happens here. And so that is to do Boolean subsetting or logical subsetting. And the basic idea behind logical subsetting is because the elements of a vector are ordered, I can then create a set of true false conditions that are the same length as the vector. So if I've got 6 names, then I could create a set of 6 trues and falses. And that set of 6 trues and falses will be used to grab the pieces out that I want. So this is kind of like walking up to the counter and saying, I'm going to go over every single element in the entire bakery case, and I'm just going to tell you yes or no as I get to it. So yes, I want that one. Yes, I want that one. No, I don't want that one. No, I don't want that one. Yes, I want that one. No, I don't want that one. Yes, I want that one. Yes, I want that one. No, I don't want that one. So what that requires me to do is it requires me to point at every single element in the bakery case, or it requires me to point at every single element in my vector and say yes or no, I do want that, or no, I don't want that. And the way that R thinks about yeses and nos is trues and falses. So do I want this thing? True. Do I want this thing? False. Do I want this thing? True. Do I want this thing? False. Do I want this thing? False. And so that would equate to like, okay, yeah, grab this one, don't leave that one behind, grab this one, leave that one behind, leave that one behind. Um, so this is all this is the idea of Boolean subsetting or logical subsetting. And unlike the positional subsetting, where positive positional subsetting says, I'm going to point at that thing, I want this thing, or negative position subsetting where you say, I want the whole case except for that thing. I don't want that thing. I don't want the item in position 2. So do not give me the item in position 2. That's what the negative 2 is there doing. And here says, I don't want anything except for the item in position 3. Well, Boolean subsetting does not allow you to point at the individual things that you want or don't want. It says, all right, we're going to go through every single thing in this case, and you're going to tell me, do you want this true or false? Okay. So let's think that requires us to know a little bit of the rules of logic. Okay. So if I have two circles, I've got this circle is y and this circle is x. So this would be give me everything in y and not in x. So that this bang operator, this exclamation point says, don't give me anything in x. All right. This is, or is it, oh, I'm sorry. This one is, does that make sense? So this is x. I think this is mislabeled, unless I'm misunderstanding this picture. Or maybe it's oh, you know what? I think the gray is what's actually been, the gray is what we're actually selecting. Oh, yeah, yeah, it's the gray. So the gray is the selected value. So let me think through this again. So this says, give me all of the things in Y that do not belong to X. So that's just this moon over here. So that's everything in this circle is Y, but I don't want the stuff that's also in X. So give me this stuff over here. This circle is just X. So if I say give me X, it's going to give me everything in X. It doesn't matter whether it's in Y or not. As long as it's in X, then we're good. This one is saying X or Y. So this up and down pipe is the or symbol. So that says if it's in X or if it's in Y, doesn't matter. Give me everything. This says and, so it has to be both in X and also in Y, and we're going to get this intersection in the middle. I don't know how to pronounce this, the XOR operator maybe, or XOR operator. I'm not sure, just XOR. I didn't grow up doing computer logic. I'm sorry. So that says, give me the stuff in X or the stuff in Y, but not the stuff that is both in X and Y. So this is basically saying X or Y minus X and Y. So just give me the stuff that there's no overlap in. And this is saying, give me the things in X that do not belong in Y. So that's this not operator, so not Y. And then here's Y. All right. So the logical operators in R, so if we've got X is true and Y is false, then the or question is, are either X or Y true? And so X or Y is true because at least one of them is true. The and operator is going to be false because the and operator is asking, are they both true? So if Y is false, then no, it's not possible for both of them to be true. So this is false. And then the not operator, this is saying what is the opposite of this thing. And so what is the opposite of true? Well, the opposite of true is false. So that's why we're going to be seeing false here. So as I just mentioned earlier, as I was kind of working through this in my head, the XOR or XOR operator is give me X or Y and the things that are not in the intersection of X and Y. And so, yeah, are X or Y true, but not both. So as long as one of these is false, then this XOR operator is going to, if one of them is false, not the other one of them's true, one of them's false, then the XOR operator is going to be true. And then this is actually a really, really helpful function. So right here, if you don't want to try to go through and do a whole bunch of logical checks with or, so do I want to find out if A is equal to 1 or if A is equal to 2 or if A is equal to 3, then I can use the in operator. So this is an infix operator because it sits in the middle of two arguments. So there's A, and then the infix operator sits in between A and the vector 1, 2, and 3. And that is saying, is A an like is A, which 2 in this case, is that a member of this set? And that's true because 2 is right here. All right, and we're going to pause here and we'll pick back up with repeating values. So we're still working on how to build logical vectors because if we want to do logical or Boolean subsetting, we need logical vectors. All right, see you next time.